Oh my, so this is the part 3 of my extreme values of functions video. Okay, so anyway, it all started with this slide right here when I made part 1, and you'd have to go back and look at that in order to get all caught up on where we are right now. Okay, so I'll refer you to that if needed be, but I'll start with this one, and then I'll do one more problem that has several parts to it, and then that'll be the end of this particular topic. So, okay, this problem here says find the absolute extrema, meaning the absolute maximum and the absolute minimum of this function on that interval right there. Okay, so anyway, what I noticed about this interval, it's being different than the other problems I showed you so far, is that it says our window is 1 less than x less than or equal to 4. So it's not a closed interval. It's open on the left. The 1 is not actually part of that window. Okay? So I decided, well, I think we can do this one just by knowing a little bit about the graph, and that's probably the right approach. Since it's not a closed interval, we don't go through the procedure that we've been doing with the other problems. Like let's look all the way back here. For example, this problem, find the absolute maximum and minimum on that interval of this function. Well, the way that you do that is you find the critical number, and then you make a table with the left endpoint of the interval, which is -1, the right endpoint of the interval, which is 4, and the critical number, and you compare the values that you get, and you'll notice that 1 is larger than the others, and 1 is smaller, and that's the absolute maximum minimum. That's for a closed interval, where the left and right endpoints are included in it. Here, the left endpoint's not included, so we can't do it that way. So we'll just look at the graph. About this graph, it has a vertical asymptote at 1. Notice that that's undefined at 1. 1 makes the denominator 0. Well, that's why we can't include 1 in this window, because there's nothing there. Okay? There's a vertical asymptote. The curve climbs to infinity in this case at 1. All right? So it's got a vertical asymptote at 1 and a horizontal asymptote at the x-axis. Okay, so it looks like that. Now, where are we looking? We're looking at the window from to the right of 1 over to 4. So that's going to be, well, I don't know, say 4 is about right there. Then our window might be like something like this. Okay, there's our window. Maybe like that. The curve climbs up to infinity as you go to 1 from the right. And then if you go over to 4, you'll get like that point. All right. So on the interval from 1 to 4, not including the 1, including the 4, there will only be an absolute minimum. There won't be a maximum because the curve shoots up to infinity at 1. Okay. Without even getting to the 1, it's just going to climb up to infinity as you go that direction. So, well, that's a picture looks like this. That's my conclusion based on it, being that this graph is not that hard to sketch as it is. So let's say about this one, there is going to be no absolute maximum on that interval for this curve. There just can't be a point that is the highest because it climbs to infinity within that window. And then the absolute minimum is going to be 4 for x, corresponding to this point right there, 4 for x. And then what's the y coordinate? It's going to be 3 over 4 minus 1, the y coordinate of the point. 3 over 4 minus 1 is 3 over 3, which is 1. All right, so 4 and 1. Okay, no absolute maximum. Impossible to have a point that is the highest, but there is a lowest point on the window. It's that one right there, and it has coordinates 4 for x and 1 for y. Okay, so that's how that one goes. But when the one side's open, meaning that the endpoint's not included, we'll have to know a little bit about what the graph looks like in order to figure out about whether or not there is an absolute maximum or minimum. Okay. Anyway, all right, so let's do one more problem that has like 20 parts to it. But anyway, so let me describe the setup of this next problem to you. So suppose there's these two mountains in this valley between them, all right? So, and we want to build a road to connect point A to point B, all right? And my picture is qualitatively correct, but it's not to scale. This road is like meets the slope of this mountain smoothly and the slope of that one. It looks to me like it's running into it at an angle when I drew it, but let's say it meets it smoothly. Like the side of this mountain has a 6% grade. That means its slope, when we talk about a road having a grade to it, to say that the grade is 6%, the slope is going to be 6 over 100. Okay? All right, so that's that. And this one has a 4% grade. And so that means that the slope is 4 out of 100. Okay, so that's what we mean by that when we give the grade of a road. It translates to the slope. And 6% is 6 out of 100, and 4% is 4 out of 100. This will be connected smoothly, so it's like the slope right there of this road matches the slope of the mountain in the road that's already on the mountain. Say there's a road on the mountain already, and then there's a road on this one. So that road we're building meets these like seamlessly, okay? And this is not a bridge. We're gonna fill all this in, okay, this valley right here, so that it supports this road that connects point A to B on those mountains. All right, so that scenario, that's what we're up against in this problem. Now, I want, in order to do some math for this one, I need to maybe make a more detailed picture, okay? So here's without the mountains drawn. We want to build a road to connect point A to point B, okay? So that's this. This is the road on that one side of the mountain, having a 4% grade, meaning the slope is 0.04, 4 over 100, 1 over 25, whatever you want. I'm just going to say m is 0.04. And over here, the slope is, the grade is 6%. I'm going to say m is negative 0.06. It's going downward. It's falling, whereas this one's rising. Okay? All right, so now I've taken the mountains out of the picture. Now we're just looking at the lines. Now take it a little further. We get a coordinate system, okay? Because that's normally the frame of reference that we use for doing math is a coordinate system. So what you should see is the same picture so far, but like this, all right? Y-axis, x-axis, point A, point B. And then there's one additional piece of information I'll give you. I'll say once we impose the coordinate system, point B and point A are each 500 feet from the y-axis, okay? All right, so that's what we do. That's what we got. Now, my first question for you is this. What are the coordinates of point A? Given that I took my scenario of the road connecting 2 points on these mountains, all right, and I put a coordinate system on it and so on and so forth. What are the coordinates of point A? What are the coordinates of point B? Okay, well, let's do that this way. What do you know about that point in this road or this line that it's on? Okay, the slope of this was what? We said it had a 4% grade. The slope is 0.04. Maybe I'll say 4 out of 100. Okay, and what about this one? Well, then the slope of that line right there, okay, is 6%, all right, 6% grade, 6 over 100, or negative 0.06. I'll do, for that one, I'll say m is equal to negative 6 over 100, like that. Okay, anyway, so let's do like this. To find the coordinates of this point, I know that point's 500 to the right, and I know this point's 500 to the left. I know the x-coordinate. So the coordinates of point A are going to be negative 500 for the x-coordinate because you go left 500. And the y-coordinate, well, we got to figure that out. And the coordinates of point B are 500 for the x coordinate, because you go right 500. And then the y coordinate, we got to figure that out. But to figure that out, we could do it like this. What do you know about like this line right here? It reaches that point. This road connects up to B, but what do you know about this? It has a slope of 4 over 100. That means right 100, up 4. Right 100, up 4. So wouldn't it have to be the case that if you went right 500, that you would go up 20? 4 to over 100 is 20 over 500. All right? So right 100, up 4, right 100. So that's right 500, up 20. So the y coordinate of point B is 20. Okay? And what about point A? So for this line right here, it's left 100, up 6. Left 100, up 6, like that. So let's do the same kind of thing with that. If I go left 500, I'll have to go up 30, all right? So that's going to be a 500 and a 30. To match up with that road right there projecting downward, 6 to 100. So the y coordinate of that point right there, that's going to be 30. All right. So point A, negative 500 for x, 30 for y. All right. So maybe that first part wasn't so bad. It's probably harder to just take in all the information that you see in the question, but all right. So say we got that far, and I give you point A and point B. Okay. Now time for the next phase of the question. All right. So let's do this. The dashed curve where the road is to be built is parabolic. All right. So it's going to be a curve that dips downward and kind of intersects seamlessly with point A and B on the mountains, and then the roads that are projected from there. So it's parabolic. It has as all parabolas do, it has equation y equals ax squared plus bx plus c for x between negative 500 and 500. So that's this road we're going to build that's parabolic, that takes you from point A to point B. That does span from our coordinate system, negative 500 feet to the left, 500 feet to the right. Can you find this function? In other words, can you find A, B, and C? All right. So, well, here's what we know about it so far. Let me do this. So y is equal to ax squared plus bx plus c. That's the equation for the curve, all right? This parabolic road, this arc. And y prime, what's the derivative of that? 2ax plus b. Okay, so I'll give you both of those. What's the reason for that? The reason is that because at this point, I know how steep the road should be. See point B right there? I know how steep it is right there. And you see point A right there? I know how steep the road is right there. It's got a slope of negative 0.06 at point A and a slope of 0.04 at point B. So I know something about this. All right? So let's say from here, y prime is going to be equal to 0.04 at point B, and y prime is going to be negative 0.06 at point A. That will translate into this. What's y prime? 2ax plus b is equal to 0.04 at point B, and 2ax plus b is negative 0.06 at A. Do we know anything else about that? Well, yeah, we know the coordinates for point A and point B. So we should use that information too. Like the x coordinates, negative 500 and 500 for points A and B. Okay, so let's see. So at point B, the x-coordinate's 500. So I'll get this. I'll get 1000 A plus B equals 0.04. I'll get negative 1000 A plus B is negative 0.06. Because at points B and A, x is 500 and x is negative 500. Okay? All right, now what can I do? Well, it's ultimately I wanted to solve for A, B, and C. I can add these two equations together. It will eliminate the A, and I can solve for the B. So 2B is equal to negative 0.02. Okay? Or, if I divide by 2, I'll get B is equal to negative 0.01. All right, so I got B, okay? Now I'll find A with B. So look over here at either of those. Put the fact that you know B is negative 0.01 in and solve for the A. Like if I use this one, for example, here's how I would do it. I get 0.04, all right, and I'm going to put B in. B's negative 0.01. I'm going to move that over. That's going to be plus 0.01. So I get 0.05, and I'll divide by 1,000. And I get this number. A is 0.0040 zeros and then a 5. Okay? All right, so there's A and B. So let's pause for a second. I'm trying to find this function. Here's what I know so far. Okay? Now, I've got that y equals ax squared. So I know a is this number. Plus bx. I know b is this number. Plus c. Okay? So the only thing I don't know at this point is c. So how can I find that last constant in this equation? Well, okay, I happen to know 2 points, right? Again, I know that this point is on that curve, point B, and point A is also on the curve. I got their coordinates. I could use either one of them, okay? So for either one of these, I could say, well, if x is 500 and y is supposed to be 20, and I can solve for c. Or I could put here, x is negative 500 and y is supposed to be 30, and then I can solve for c. Okay? All right, so like it doesn't matter then. So how about this? I'll say, well, if I take that one, and if I let x be, how about this? Since it doesn't matter, I'll use this one. Okay? So I'll let x be 500, and I'll let y be 20, and I'll just put them in. Okay? Solve for c. It's pretty easy to do with a calculator. So you'll get c is equal to 12.5. All right? All right, so here's my final answer. The equation of this parabolic curve right there is this, but that last number c is 12.5. So that'll be my answer. Instead of writing the whole thing all over again, I'm going to just put my 12.5 right there, and there is my final answer. Okay, so now I know the equation of the arc that's created by that road. You're looking at it right here. Okay, so let's do 2 more things with this one. So, all right, so here's my picture again, and I have the equation updated on it, and I have my points and so on. And next we might hear a question that goes like this. How deep should the road be filled? So remember my initial problem is I said, well, okay, I got these 2 mountains. I've got roads on the mountains already. I want to build this road that connects point A to point B smoothly. And I'm going to fill in this valley and build the road on top of it, okay? So I need to fill in the valley to a certain depth at each point to create this road. So say we get the question like this: how deep should the road be filled? Like how deep in here? Because remember, this is the mountain and this is the other mountain, and I'm going to fill in the valley. So how deep should the road be filled at the point where x is negative 500 and at the point where x is negative 400? Well, so at the point where x is negative 500, you're on the mountain, okay? If you keep going, well, then you're on the road between the mountains. But right there, you're on it. You don't need to fill anything. The fill depth is the difference between this and this. Like here, there's the road on the mountain. But if I project the mountain down into the valley, then it's like right in here. And same thing with that one. Okay, so for this one, the depth is 0 feet. Okay, but what about that one? What if at position negative 400? Well, that might be like, so if that's 500 feet to the left, that, I don't know, somewhere over here. I need to find out the y-coordinate of that point minus, like, however high up this is. Okay? All right, so let's do like this. To find the y-coordinate of this point, we'll put negative 500 in there. Okay? So for this one, let's do like this. Let's say 0.00005 times negative 500 squared minus 0.01 times negative 500 plus 12.5. And then, so I got to do all that, and I have to subtract this distance right there. Okay? Now, what do we know about this? Let's think back to the beginning. That's got a 6% grade over here. So the slope is 6 over 100. Okay. So if the slope of this is 6%, or 6 out of 100, then what if this was 400 that way? How far up would this be? The rise is 6, the run is 100. If the run is 400, the rise is 4 times 6 is 24. 24. So we want to do like that point right here is 24 feet up. So the fill depth is that y-coordinate, which you see here, minus 24. Okay? Which is how high the slope of the mountain is in that valley. All right. So I'm going to pause it, type all that stuff in my calculator and show you what I get. All right. Pause real quick. Okay, so if you do all this, you get 0.5 feet. So at that point here, 400 feet to the left, we only have to fill half a foot above the mountainside up on the road. And then like if we were like building this, like we'd have to sample like every so many feet, how high up do we need to fill it to close all that in and make this road smooth and connect seamlessly to these points. But it's 0.5 feet. Also, I realized I made a mistake. I should have put 400, negative 400 in both of these. I accidentally wrote negative 500, all right? So I found the y-coordinate here by putting negative 400 in to that, and then I subtracted 24 feet up, which is how high up the slope of that mountain is at that spot. I subtract them, I get half a foot, okay? All right. So next thing, one last thing, okay? Because you could do any others like this. Any other, if I say negative 300, negative 200, you could figure it out the same way. Last thing, what's the lowest point on the road? Well, I guess this comes, like circles all the way back around to where we started this. How do you find the absolute maximum or minimum point on a curve? Let me find one of my slides from before in order to show you. So we could say that, well, I don't know, like take this curve right here. That highest point is such that the derivative is 0 there, okay? Or like with this one, that lowest point is such that the derivative is 0. So to find the lowest point on the road described by this equation, where like every spot on that road has measurements to it described by that equation, it would just be a matter of finding the derivative and setting it equal to 0. Okay? All right, so there's y, right? Negative 0.00005x squared minus 0.01x plus 12.5. Y prime is going to be 0.0001x minus 0.01. And if I was to set that equal to 0 and divide, then I would get x is equal to 100. Take 0.01 divided by 0.0001. So the lowest point on the road is 100 feet to the right of the y-axis, it turns out. It's not directly in the middle, okay? All right, so that's the x-coordinate of the lowest point. I should give the y-coordinate also. So I'll put in 100 into that to tell you the y-coordinate. Okay, and it turns out we get y to be 12. All right, so the lowest point on the road with respect to our coordinate system is 100 feet over and 12 feet up. 100 feet over, 12 feet up. All right, so I'll give it that way, or like this. Give it as a point or the individual numbers, it doesn't really matter.